So far we've talked about two other forms of quadratic functions. We talked about standard form and we talked about vertex form. A third form is called factored form. A polynomial is in factored form when it is expressed as a product of one or more polynomials. So we also have been reviewing how to factor. So let's just start with this first example. Factor the expression x squared plus 2x minus 8. Since the leading coefficient is 1, I can look at this back constant, the negative 8, and consider the factors of negative 8 that would add up to 2. So I'm going to do some scratch work over here. The factors of negative 8 could be 1 times 8 or 2 times 4. Now, it does need to multiply to make a negative, so I am going to use one positive and one negative number, and I need it so that it will add up to a positive 2. So I'm going to use negative 2 and positive 4. Multiplying those together gives me negative 8. Negative 2 plus 4 is equal to positive 2. So those are my factors that I'm going to use to write the factored form x minus 2, x plus 4. To the right, I've also included the graph of the function y equals x squared plus 2x minus 8. Let's compare. How do the factors that we just got for x squared plus 2x minus 8 relate to the zeros in that function that's graphed? Y equals x squared plus 2x minus 8. Highlighting a couple of things here. Notice we're looking at a polynomial quadratic versus the function of the same form, x squared plus 2x minus 8. We also can see my factors were x minus 2, x plus 4. What are the x-intercepts over there? On the left, our x-intercept is negative 4. On the right, our x-intercept is 2. Do you notice anything? Very similar. In fact, what if I took x minus 2 and set it equal to 0 and solved it? I would get a positive 2. What if I took x plus 4 and set it equal to 0 and solved? I would get negative 4. So I factored the expression, I graphed the function, and I am seeing that the factors are revealing those x-intercepts. I do have that written out here below. When a quadratic is written in this factored form, each factor can be set equal to 0 to find the zeros, or recall those are our x-intercepts of our graph. So this can actually help us very easy when our quadratic is already in this factored form to identify those x-intercepts. Let's look at our first couple of examples. Which equation best matches the graph shown below? And we've got multiple choice here. We're going to use some qualities about quadratics that we know already. I know this is a smiley face opening upward parabola. Therefore, my a value is going to be greater than 0 or positive. So I do want to go through and eliminate any answer choices that have a negative leading coefficient or a value. That's going to eliminate the top left and bottom right answer choices. We're also intersecting at 3 and 6. So our x-intercepts are 3 and 6. In factored form, I should see x minus 3, right? Because we just said when it's in factored form, we could set the factors equal to 0, and solving them would give us our x-intercepts. My other factor is going to be x minus 6. So I need both of the factors to show subtraction so that my x-intercepts are positive. It looks like that top right answer choice is our correct answer choice. In number 2, we have that frowny face parabola, or it's opening downward. That means our a value is less than 0 or negative. I'm going to do the same thing we did before. So I'm eliminating these that are positive because those would be smiley face open up parabolas. So those left ones are out. We do see it in the right answer choices at negative a value. In this example, we have an x-intercept that is negative 1. Therefore, the factor should show x plus 1. I'm seeing that in the top right. And our second x-intercept is positive 2, so my factor should show x minus 2. Again, seeing that in the top right there. What about when we're not provided the graph? We can still solve our quadratics by factoring. I've provided some steps for you. Number 1, we do want to make sure that we write our quadratic in standard form if necessary. Recall that is going to be x squared plus bx plus c equals 0. So we just want to make sure our entire equation is equal to 0 before we get started. Check for a GCF. This can help us factor. Complete the factoring process, and then we'll set each of those factors equal to 0, and we'll solve. So on number 3, we have x squared plus 7x plus 3 equals 3. Step number 1, set it equal to 0. I don't want equals 3. I want equals to 0. So let's subtract this 3 on the right side, and doing the same thing on both sides, rules of equality. I get x squared plus 7x. Actually, those cancel as well on the left side, equals 0. Step 2, check for a GCF. Okay, what does x squared and 7x have in common? Nx. So let's remove an x GCF. Is there any more factoring I can do? Step 3. Nope, it is factored. So we're ready for step 4. Set each of those factors. We have 2 factors here. The x, set it equal to 0, and the x plus 7, set it equal to 0. Solve each of those for your x-intercepts. We already have x equals 0. It is done. So one of our x-intercepts is actually at the origin. On the second one, x plus 7, subtract the 7 from both sides. Our other x-intercept is negative 7. So solving number 3 by factoring, our x-intercepts would be at 0 and negative 7. If I graphed the related function, I would see that. In number 4, we have x squared plus 8x minus 11 equals 6x minus 8. Again, we want it equal to 0. So let's subtract the 6x away from the right side. I'm going to line it up with like terms on the left side. What we do to one side, we got to do the other. I'm also, hope I don't ruin your brain here, going to add 8 on both sides, doing kind of 2 steps at once. Our new polynomial is going to say x squared plus 2x minus 3 equals 0. Is there a GCF? There is not. We're ready to factor. Leading coefficient here is a 1, so I can just consider the factors of negative 3. That would add up to a 2, making some scratch notes over here. Our only option is 1 and 3. To make it add up to a positive 2, I'm going to make that larger number the positive. So we have negative 1 and positive 3. My factored form being x minus 1 and x plus 3 is equal to 0. Step 4, set each of those factors equal to 0 and solve. Adding 1 to both sides on our first factor here, our x-intercept is going to be a positive 1. Subtracting 3 on our second factor equation, we're going to get x equals negative 3. If I was to graph this related polynomial quadratic on a coordinate plane, it would intersect the x-axis at 1 and negative 3. Number 5, step 1, put it into standard form. We've got a positive 6x, so let me subtract 6x from both sides. Also, 2 steps at once, I'm going to add 5 to both sides. That's going to cancel everything on my right side. Our new quadratic, x squared, our 6's canceled there, and we have minus 36 equals 0. Check for a GCF. Nope. Step 3, we're looking for factoring x squared minus 36. I hope you noticed that this is a difference of perfect squares. Therefore, you need to know that formula. The square root of an x squared is an x. The square root of 36 is 6. So this is going to look like x plus 6, x minus 6 is our factored form. Setting each of those equal to 0 and solving, our x-intercepts are going to be negative 6 and positive 6. Lots of different types of quadratics, lots of different ways to factor. I've got an example of each here. Number 6, 5x squared plus 7x minus 4 equals negative 7x minus 1. Again, we need it in standard form equal to 0 before we can start to factor. So I'm going to add the 7x to both sides, also adding 1 to both sides to eliminate everything on the right side. Our new quadratic, 5x squared plus 14x minus 3 equals 0. Now this time our leading coefficient is 5. I should multiply the 5 times the 3, gives me negative 15. I'm thinking about factors of negative 15 that will add up to positive 14. That's going to be 15 and negative 1. We use those factors to rewrite the center term. 5x squared, you can choose your order here. I'm going to go with 15x first, minus 1x minus 3, making this polynomial into 4 terms. So we can continue with the grouping method. I'm going to group first term, second term together. This is not my factored form. I'm looking for GCFs in each. GCF in the first group is a 5x. GCF in the second group, I'm going to look and see, I think I can use a -1. So removing that GCF 5x in the first term leaves an x plus 3. I'm liking the way this is looking. Removing the GCF of -1 in the second group, we have x plus 3. Remember, we want those in the parentheses to match. That is my check to make sure that I did multiply this correctly or factor this correctly. Our first factor is 5x minus 1, pulling those GCFs out front. And we write that repeating parentheses once, the x plus 3. That's my factored form. Last step, set each of those equal to 0 and solve will give me my x-intercepts. We would have to add 1 to both sides on this first factor, getting 5x equals 1, dividing by 5 on both sides. Our first x-intercept is 1/5. Hey, it could happen. Our parabolas don't necessarily have to cross at perfect ordered pairs. On the second one, subtracting 3 from both sides, our other x-intercept's a -3. On our last section here, this is actually a review from earlier in the year, determining those positive and negative intervals. We've done this section before. We've done these notes before. I did pick different examples for our graphs. Number 8, part A, the graph of y equals f of x is shown below. Find all the values of x, the domain, for which f of x is less than 0. That's a less than symbol. So we're talking about where is it negative. My negative segments are these two outer pieces. There's 2 parts here. So I can say all the x values that are less to the left than -4, or all the x values that are greater to the right of 0. That is how we write our answer, showing the intervals that are negative. Part B, using that same graph, find the values that are greater than 0. That's our greater than symbol. Therefore, where is it positive? The positive segment is that hump at the top. So we can say from -4, less than x, less than 0. Or some of you might want to use parentheses, -4 to 0 parentheses. Either form would work. Number 9A, determine the domain on which the graph is negative. Doing the same thing, just the question is written a little bit differently. On this one, the negative portion is that lower part, and that is going to be from -7 is less than x, less than 1. You might also choose to use those parentheses, -7 to 1 parentheses. You can write it either way for that compound inequality. Part B, determine the domain where it's positive above the x-axis. We've got 2 pieces here. We've got where x is less than -7 or where x is greater than 1. So there's factored form of a quadratic function. Noticing how the factors in our factored form do reveal those x-intercepts. It is opposite signs there. If I had x minus 2 in my factors, my x-intercept is a +2. We had that example at the very beginning. And then we looked at other key features with those multiple choice questions. We practiced factoring our quadratics. And then lastly, those positive and negative intervals, which is review from earlier in the year. Guys, let me know if you have questions, and I'll see you in class.